NASA built an AI to hunt for planets. It worked. In a single release, it confirmed 301 new worlds that human researchers hadn't gotten to yet. Then, using a completely different telescope, scientists found something in the sky that shouldn't exist at all. Not a planet. Not a star. Something in between that two separate scientific fields are still actively arguing about. Here's how exoplanet hunting actually works, because the method itself is almost as strange as the discoveries. You can't see most exoplanets directly. They're too small, too dim, buried in the glare of stars trillions of miles away. So instead, NASA's Kepler telescope watched for something subtler, a star's brightness dipping, ever so slightly, at perfectly regular intervals, the shadow of a planet crossing in front of it. Kepler stared at over 150,000 stars for 9 years. That produced an almost unmanageable amount of data. Millions of tiny brightness dips, most of them meaningless, noise, star spots, binary stars, instrument glitches. Buried in there somewhere, real planets. Sorting the real signal from the noise used to take human astronomers months, sometimes years, per candidate. So NASA tried something different. Instead of having humans check every single blip by eye, they built a machine that could learn to recognize a real planet's signature on its own. The first version of this idea came in 2017, when a Google AI researcher and an astronomer trained a neural network on thousands of already confirmed Kepler signals, teaching it what a genuine planet's transit actually looks like, buried in noisy data. That system found 2 new planets on its own, including an 8th planet around a star called Kepler 90, tying that system with our own solar system for the most known planets orbiting a single star. Then, in 2021, NASA's team built something more advanced, a neural network called ExoMiner. Unlike a black box that just spits out a yes or no, ExoMiner could actually show its work, pointing to the specific features in the data that convinced it something was real. In one release, it confirmed 301 new exoplanets at once, pulled directly from the leftover, unresolved candidates sitting in Kepler's archive. 301, confirmed in a single announcement. The project lead put it simply, when ExoMiner says something is a planet, you can be sure it's a planet. Add that up across every mission, every method, going back to 1992, and in March 2022, the total confirmed exoplanet count crossed a real, official milestone. 5,000 confirmed exoplanets. Not all found by AI. Not all found in 2 years. 3 decades of astronomers, telescopes, and yes, increasingly, machine learning, all contributing to one number. But that number reveals something important on its own. We now know our galaxy is saturated with planets, likely containing more planets than stars. And the tools finding them keep getting faster. Which brings us to the part of this story that has nothing to do with counting planets, and everything to do with something nobody expected to find at all. In 2023, using the James Webb Space Telescope, scientists surveyed the Orion Nebula, a massive stellar nursery about 1,350 light-years away. They found roughly 40 pairs of free-floating, Jupiter-sized objects, drifting through space, attached to no star at all. They're too small to be stars. They don't orbit anything, so by the normal definition, they're not really planets either. And strangest of all, they're moving in pairs, orbiting each other, like a miniature binary star system made of something that isn't supposed to exist on its own. Researchers nicknamed them jumbos. Jupiter mass binary objects. One ESA scientist working on the discovery put it bluntly, there's something wrong with our understanding of planet formation, star formation, or both. They shouldn't exist. So what are the leading theories? One idea. These objects form the same way stars do, condensing directly out of the nebula's gas and dust, but in regions where there simply wasn't enough material to finish the job and ignite into an actual star. Essentially, failed stars, small enough to look like planets. Another idea: they formed the normal way, around actual stars, then got violently ejected, flung out of their solar systems entirely by gravitational chaos, only to somehow end up gravitationally bound to each other afterward. A genuinely unlikely sequence of events happening 40 separate times in one small patch of sky. Neither explanation fits comfortably into existing models. Both require some genuinely new physics, or at minimum, a real update to how we think planets and stars are born. And here's the part that makes this story even more interesting. Not everyone agrees these things are even real. In 2024, a Penn State astronomer named Kevin Luhman reanalyzed the same JWST observations and proposed a very different explanation: that at least some of the objects identified as jumbos might actually be distant background objects, unrelated stars or galaxies that happen to land in the same patch of sky as the Orion Nebula. Essentially cosmic photobombs mistaken for something new. That's not a small disagreement. That's a live, ongoing scientific debate about whether an entire new category of object exists at all. Which is exactly why James Webb keeps going back. Follow-up observations are specifically targeting the precise masses, temperatures, and atmospheric compositions of these objects. Data detailed enough to finally settle whether they're genuine free-floating planetary pairs, failed stars, or simply a very convincing coincidence of background objects. Researchers have also started checking other star-forming regions across the galaxy to see whether jumbos, if they're real, are a one-off oddity in Orion or a common outcome of star formation everywhere. None of this changes the real, verified achievement. AI has genuinely transformed how fast we can confirm new worlds, turning years of manual analysis into automated, explainable results at a scale human astronomers alone couldn't match. But the jumbo story is a reminder that even with better tools finding more planets faster than ever, the universe can still hand scientists something that doesn't fit any existing box at all, not confidently a planet, not a star, and possibly, according to at least one team, not even really there. If that's the kind of open, unresolved mystery that gets you excited about space, that's exactly the right reaction. Subscribe for more deep dives into the discoveries science hasn't fully figured out yet. And tell me in the comments, do you think jumbos are real or background objects mistaken for something